All right, so let's get into the tube mill. What am I looking at here? It kind of this image right here, what you're saying, it looks like a solar panel, and I'm not sure that those are even remotely close to being the same thing. But what is a tube mill, and explain what we're looking at here?
Sure. So a tube mill is kind of a misunderstood thing. If you look around, you'll see all kinds of applications where they're round tubes, like a chain link fence is a good example. Those posts that go on the ground are round tubes that are galvanized steel. So how do they make them round, and how do they galvanize them? There's several different ways. In this particular case, this is the backside of a solar cell. And you'll see there's a round tube that the solar cell is mounted to. That actually started out as a flat sheet of galvanized steel. And galvanized steel is steel that's gone through a hot dip galvanizing process, and the galvanizing is zinc. So it's another name for zinc when you say galvanizing. It's called galvanizing because the process is galvanizing, and they galvanize zinc onto the tube. So in this particular case, the purpose of that tube is to allow that solar panel to track the sun. So it's pretty cool. So they actually have a control system on there that as the sun rises, it actually seeks where the brightest part of the sun is, and that'll change in angle as the day goes on. And the reason it can do that, it's on a tube that can pivot and allow it to do that. So let's take a look at how this tube is made. First of all, this is the thermal spray process that's used for the tube. I just want to explain this a little bit before you saw the video of the tube mill, so you know what's going to be going on. On the very top there, you see the round spools. That's where the zinc wire is. And we switched them over to drums of wire later on. This is when we first started up. We just started with the spools. The gray box up there on the top, that's the wire feed unit. There's short coaxial cables that go down to the blue box on the bottom there. And you see there's like a blue glow in that box?
Yeah.
That's actually the thermal spray process that's arcing two wires of zinc together and creating molten zinc that's spraying onto the tube. So you'll see this in the video, and now you'll understand when the video comes up, you'll understand what this whole process is doing. So here is the video of it. We're starting off with a flat sheet of galvanized steel. It's just regular steel that they hot dip galvanize. It comes through, and it comes through the first set of forming rolls, and you'll see that it puts a little bit of a curve in that sheet. And each one of these forming rolls curves it a bit more, and a bit more, and a bit more. It gets to the point that it's a U-shaped, and then the last dies roll it up into a tube. Then as it comes through, it comes to, and I'm going to ask you to stop it when we get up here in a minute here. And it comes right up here. You see it's now formed into a tube. And stop it right here a minute. What we're looking at here is this is an induction heating unit. And they're doing a friction weld. And it's actually, what happens is they have an induction coil around there. You see that round coil around the tube on the bottom of the picture there. That has a high frequency electric current going through it that's inducing electricity into the tube. And they have a piece of steel inside, and they call it a ballast. And that piece of steel inside, this ballast focuses that electromagnetic energy to the center where those two tubes are coming together. And it gets it so hot, it gets it glowing red, and the last die pushes it together and does an upset weld. So there's no weld rod. There's nothing there. It just forms it up, and it actually compresses it together, and the two red hot pieces of steel weld together. So you'll see that occurring, and right after that, they have what's called the scarfing tool. And what they're scarfing off is that does the upset weld. There's a little bead of steel that comes out on the top, and they actually shave that off to make the tube round again. So let's move the video ahead a little bit more, and you'll see that happening. So it goes through the induction heating. You see it's red hot. And there's that, if you stop it right there a second. So good, you stopped it right here, and you see that red color there. That's actually that tube right along where those two seams are coming together got so hot that you were able to upset weld that. So the tubes came together, the forming tool there, the roll former, pushed those two pieces of steel together, and they actually formed a bead, and it raised above the tube. And right after that, you'll see what's called a scarfing tool that scarfs off that bead. We have another follow-on video here that you'll see this much clearer. And you'll see where we're scarfing off that raised piece of metal. Now, what's important about that is that's still extremely hot. And now it goes to the thermal spray process right there, where we're spraying the molten zinc on top of a very hot piece of steel that just came through and was hot enough that it was glowing red. And the zinc sticks to that when we now regalvanize that weld seam. So when they did the actual welding part, that was so hot that the zinc melted off where the weld was. And now what we're doing is we're putting the zinc back on where we're taking it off from the scarfing tool.
It's fascinating to me that this all, I know that this is an enclosed building, but it does feel kind of just happening out in the open. And the way you're able to just video all this happening, and I'm sure to everybody in that building, it's a pretty normal process, but it's fascinating to watch and just to see that happen, all these different moving parts. Is there an advantage or disadvantage? Obviously, this has been perfected over time to bending the metal in that way. Obviously, the slower you do it, it probably is better for the integrity of the metal.
Well, this moves pretty fast. Actually, some of these mills go up to 300 foot a minute. So they're running this through. And this particular day, this was still set up, and they were running the mill pretty slow. So it goes much faster, and the purpose of it is just production. Being able to crank out as many foot of this tube in the shortest amount of time that they can.
One more question, and this is just because I'm the new guy here. Is that blue water? What's going on with that water there? And what is that actually doing?
Well, it's a coolant lubricant. So you can imagine when this mill starts running up at full speed, there's a lot of friction in all those rolls. You're taking steel and rolling it into a shape, and all those rolls back there get hot. And that is actually a lubricant and a coolant to cool down the tube after they do the weld. That's why we have this thermal spray so close to the weld. We don't want water getting in there. It's hot enough that the water evaporates right away, and there's actually air jets inside there blowing away any moisture to happen to be there. And it's hot enough, if there's any lubricant on that, the lubricant actually evaporated off of that weld seam. So the zinc sticks extremely well. It actually surprised, again, this is one of those examples of if somebody asked me, could you do this? I would have said no. You got to have a rough surface. It's got to have a right texture. But the answer is yes, it does work because the steel was so hot that the molten zinc sticks very well. So this is good. This is a close-up of the scarfing operation. And you see on the right side of the frame there, that red line, that's actually a bead of metal that when that tube came together and was so hot, it welded together and the pressure caused some of the material to actually raise up. So that was extra material that's on there. And there's a sharp tool on that. And if you're a machinist, you'll know it's the same kind of tool that you use on a lathe. It's got a carbide tip on it. Because in the finished tube, you don't want to see that seam there. You want that to be even with the rest of the tube. So that's the scarf. And that's how hot it is. It's actually glowing red, which I think is somewhere around 1900 degrees Fahrenheit. Now, it cools pretty rapidly as it goes through, but it's still very hot when it gets to the point where you do the thermal spray. So let's go ahead and continue showing that. We'll stop at the thermal spray part here too. And this is where the thermal spray is occurring. It's just like 2 feet from where the scarfing is. So that tube is still very hot at this point. So inside that box, the thermal spray operation is occurring. The reason it's inside that box is to suck away all the zinc dust. You don't want that floating around the plant. So that's in a very small box. So you can have a relatively small dust collector will effectively pull all the dust in. But that like bluish glow, that's actually the arc, the 2 zinc wires coming together. So the 2 zinc wires come together, you strike an arc, and there's atomization air inside that atomizes that molten zinc, and it hits the seam, and it adheres to that hot seam where you just got done scarfing off the extra metal. And this is a close-up of the actual arc gun. You can see the 2 copper tubes there and the 2 wires coming out. They'll strike an arc there, and there's a tube in the center that has the compressed air. And right below it, you'll see the round dot where the zinc is actually spraying onto the tube itself. And what happens is the zinc sticks really well to the fresh weld area that doesn't have any zinc on it, and it doesn't stick so well to the outside of the tube. But what's interesting is as it goes through the rest of the process, that loose zinc comes off from the coolant flooding the tube and the rest of the processing. Any of the loose zinc falls off, but the bare metal is totally protected. So now they have a galvanized tube that was made. So that's why they're called tube mills. That's a mill. That whole thing that does that's called the mill, and they create a tube out of flat sheet.
It's fascinating to me how much that can be produced, but you see them everywhere. Obviously, you don't think of it anymore. It's just part of nature. There's a fence over here. There's a light post over here. But to actually see the process be made, that's fascinating. It feels like that has to be running 24 hours a day with the amount of stuff that we're seeing put out, especially with cities growing all like crazy right now, it seems like.
There's actually tube mills all over the country, and it's kind of a commodity. So they're localized because you don't want to ship tubes. Tubes don't have much weight. They take up a lot of room. Mm-hmm. So with transportation costs being so high, tube mills are relatively small mills, and they place them all over the country. So they have transportation costs to keep to a minimum. And this is the actual finished tube. And you have to look really close to see where the weld seam is, but you can see it there right in the center. And it's got a little bit of a flat area there. Yeah, as you bring that up there. And you can see the zinc covers it up, so it's completely covered and protected again. Now, sometimes they'll paint these galvanized tubes and give them color. We had one example where we did that with olive oil barrels. We had another video where we talked about olive oil barrels where they painted it afterwards.